Thank you very much for your pointing me that. Okay. Furkan says all real life signals are continuous time signals. The system is that we use the systems that we are using are digital systems. The process and analysis, the signals we need, sampling. That's what Furkan said. So the sampling is like taking samples from a continuous time signal with equal time intervals. Anya said sampling is done to convert a CT signal to a DT signal, since most costly devices easily analyze and process digital signals quickly. Very nice. Why do we do sampling? Because we use digital devices to process and analyze information, data that is coming from real life, in parentheses, sensors usually. Sensors, okay? For example, you have a sensor, humidity sensor, temperature sensor. It collects the data in an analog manner, in a continuous time manner. For example, ECG. Normally, ECG is something like that. It shows us the heartbeat, how does the heart behave, those kind of things. The electrical potentials, electrical currents that exist on the heart are all continuous time data. They all generate continuous time data, right? Değil mi arkadaşlar? So I have this continuous time data, and I would like to find out the heart rate of a person, and would like to show it on a bedside monitor. Hasta başı monitörü, bedside monitor. Do you know what bedside monitor is? Arkadaşlar? Here it shows you the heart rate, heart signal. It shows you the heart rate, 72. It shows you some other things, right? Bedside monitor, you put next to the bed of the patient so that you can monitor heart related, blood pressure related, oxygenation related data, which we call vital data. Vital, yaşamsal, vital. Okay? We are showing the doctors and nurses vital data through bedside monitor. So what do I have? I have a person like that. It has its heart, his or her heart here. We put some electrodes and collect the data through sensors. And then with some let's say filtering, amplification, and those kind of things, I amplify and remove the noise from the signal, okay, using the electrodes. Or similarly, we have the brain. We have electrodes here and one reference electrode here. We collect data from the brain. We have a system which includes filters, which includes amplifiers. Then I would like to send it to my computer and will be able to process on a computer, right? Or I would like to have this guy use these data coming from the EEG. It will be a wireless stuff. And using this, I will control a wheelchair. This is the wheelchair. Okay, the guy will sit, and then using the brain waves, he or she will control the wheelchair. electrical wheelchair, for example. So what do I need to do? I need to collect data using electrodes. In general, sensors. You know, we have a capsule next year. It's called sensor system design. You're going to use different sensors, optic-based sensors, pressures, capacitive sensors, different sensors to collect data from the physical world. Human, animals, atmosphere, anything like that. Yes, as Nur Efşan said, you can see these kind of things in the in different TV shows, right? For example, there is a doctor going inside the patient's room. Oh, the heart rate is slowing down. We should do something for this guy. Oh, the blood pressure is going down. Tansiyonu düşmüş. So we should do something for this guy, right? So it is like the guy becomes X, right? X. What does it mean, X? I don't know. I don't like this. X oldu. The patient became X. Evet. So I have this data right now, right? What should I do? I should collect this data. Ne oldu bu arada? İnternete bağlantım mı şey oldu acaba? Bir saniye arkadaşlar. Bir şeye mi dokundum? İnternetim koptu galiba. Bir saniye. iPad'im de koptu. Meeting ID'yi söyleyebilir misiniz hızlıca? Hemen
975
72
49 03 59.
Kusura bakmayın. Acaba Wi-Fi'm mı kapandı? Şöyle bir bakayım. Gerekirse telefonuma bağlanayım. Wi-Fi aranıyor. Wi-Fi'ye bağlandı şimdi herhalde. Çok özür diliyorum arkadaşlar. Şimdi bağlanıyorum. Şimdi what were I describing to you? What was I describing to you? We have the data coming from the sensors or electrodes. Now I will do some pre-processing, such as filtering and amplification. And then what is next? Then I will send it to a computer or any digital device, right? Okay, so there should be an intermediate step which converts this continuous time signal into digital world. What is the difference between digital and discrete? Do you remember we had such a discussion before?
Digital, we have like a steps, but in real time, there aren't steps. It's going further more.
Okay. Şimdi arkadaşlar bakın. Furkan said digital means 0 and 1. How about discrete time? It's not 0 and 1, right? Bakın arkadaşlar şöyle bir şey göstereyim. Continuous, discrete, continuous time, discrete time, digital. Okay, they are three different things. Or the digital doesn't mean discrete. Bakın şimdi continuous time means any time, any value. What do you understand? Any time, any value. What do you understand from this arkadaşlar? Nurefşan? What do you understand from any time, any value?
It is like infinite time. There is no restriction about it. And it can be any value.
So infinite time, what do you mean by Nurefşan infinite value? Like because it goes to infinity, that's why you are saying that?
Yes.
How about if I have only this pulse for 1 second? 1 volt, 1 second.
Hocam, can we relate it to offline analysis? Like anytime, any value?
Anytime, any value. So is it possible for me to say 0.0125? Can I know this value from this signal? If this is x of t?
Yes, sir.
Yes. Why?
Because it's the signal exists for all real values of t.
Continuous time means signal value exists anytime. So do I have this value? Yes. Do I have this value? Yes. I don't have any restrictions, right? So it is okay to have any time. So I have value here, here, here, here, anytime, any value. Any value means, so it may be 0.123 volts or 10.56001 volt, okay? So I don't have any restrictions on the voltages in general, okay? So continuous time, I have information at any time, any value. How about discrete time? Do I have any restriction on time?
There is a restriction, yes.
Yes, right? So I only have samples at certain time instants. Değil mi? Have samples at certain time instants. Anlarda, belli anlarda. Time instants, okay? At certain time instants, I have values. Do I have any restriction on the value of the signal at those time instants? Is there any restriction on the time value, voltage?
About magnitude?
About the magnitude, yes.
I don't think so.
No, right? So we don't have any restrictions on, here I have samples at certain time instance, but the data may be, again, 0.0123 volts or 10.556001 volts, okay? It may be any voltage. But in digital world, I have samples at certain time instance and also certain voltage levels, which are represented with binary, we call them code words. 01001, kind of, okay? I have voltage levels. Why? Why is my voltage level restricted to certain voltages?
Because we cannot represent the infinite value in codes.
Very nice.
Memory restriction.
I do not have enough code words to represent all voltage levels, right? Değil mi arkadaşlar? So, can I represent the difference between these two voltages? What do you think? Yes, I can, but I need to have many code words for that. For example, if I only have 1 bit, which means 0 or 1, how many levels do I have? How many code words do I have? 0 or 1. Yes, no. Right? Yes, no. 0 or 1. 0 volt, 5 volt. I don't have 3 code words. So that means I only have 2 voltage levels. If I have 2 bits to represent the voltage levels, then I would have 0, 0, 0, 1, 1, 0, 1, 1. That means now I have 4 levels. Değil mi? So that means I have 4 code words to represent or to represent that voltage level. With only 2 bits, can I represent the difference between these two things? Usually no, right? I have to have, for example, let's say 64 bits or 32 bits. I will talk about the details of this later today. So, what is specific about digital? I have samples using sampling processes and discrete, continuous to discrete, then discrete to digital, right? You remember this? Continuous time to discrete time to digital. So this is what we usually do. What is this digital conversion mean? We usually call it A to D conversion, analog to digital conversion. Okay? So I want you to realize the difference between discrete time and digital. And I will give you some more insight about this conversion and digital, let's say, digital signals. Okay, this concept, I will call them quantization. Okay, in the today or tomorrow, I will talk about the details of the quantization. Okay, are we on the same page? Continuous time. I have continuous time signals like that coming from a sensor, an electrode, from the space, from a submarine, from a plane, from an electronic circuit. I have my continuous time signal. In order to convert it and use it in my computer, in my Arduino, in my STM32 microprocessor, microcontroller, or to MATLAB, I have to first convert them into discrete time, then to digital. Okay? Because our digital devices only understand from zeros and ones. That's their language. Okay? They only understand binary language. They cannot understand 0 volt, 5 volt, 2.5 volt, something like that. Okay? Evet, so that was my goal. Why do we do sampling? because I am going to use those samples in devices to further process my data, to extract heart rate, to extract alpha wave amplitude, alpha wave, beta wave ratio, right? Or the heart or the muscle strength. Okay, so I would like to do some processing in my computer or in my microprocessor. That's why I need to do sampling. What are the critical things about sampling? Arkadaşlar, up to this point, do you have any questions? Is anything not clear on your minds in terms of sampling? Why do we need sampling? The difference between continuous time, discrete time, and digital domain. Everything is clear? I want to see some emojis, something like that. Everything is clear? Yes? Okay, very nice. I only saw a couple of them. Very nice. So let's go further. How about the concept of sampling frequency? Manal, what does sampling frequency mean?
It's 1 over t. It's 1 over the period.
1 over the period. What do you mean by 1 over the period?
How many do you call it, cycles per second?
How many cycles? For example, if I have this sine wave, then I would say this is my period. But I'm
Yes.
talking about sampling frequency. So normally, if I talk about frequency or the period, you would tell me this is my signal, periodic signal, and it has a period like that, and 1 over t will give me the frequency. Okay?
Yes.
Now, I would like you to think about the sampling frequency. What does sampling, örnekleme frekansı, sampling frequency, what is the difference between normal frequency of a periodic signal or and the sampling frequency in samples?
Hocam, is it kind of how many sampling your device take from the outside? For example, in our project, we have 128 sampling. That means our
Sampling
sensors can observe that much sampling.
Hocam, is it number of samples per second?
Yes, number of samples, as Yasir said, number of samples per second, or as Süleyman wrote in the chat, number of samples per second. For example, if I have this 6 samples in 1 second, I collect this, and what is my sampling frequency?
Six.
Are you sure? How do you determine? Let me give you again. This is my signal. I have these samples. Ne yaptın abi? İstemeden. Okay, 1, 2, 3, 4, 5. This is n, but I say this is 0, this is 1 second. What is my sampling frequency?
6 hertz.
6 hertz. Any other ideas?
5 hertz,
5 hertz, why?
because over 1 second it will start one more cycle, so we need to take it from back, like 0, 1, 2, 3, 4. It makes 5 sample.
Okay.
So
So
5.
how many intervals do I have here arkadaşlar? 1 interval here another one here, another one here, another one here, another one here. So I have one period here, another period, another period, another period. I will call them TS, and another period. TS means time interval between two samples. So how many TSs do I have?
5.
5. 1, 2, 3, 4, 5. TSs are, TS is fixed, okay? It's fixed. I'm using a sampling fixed time duration between two samples. This is my first sample, but I have to look at how much time did it did pass, how much time did pass from the first sample to the second sample. This will give me the period, right? Sampling period. How much time does it take for me to wait for the next sample to come? How much time will I wait for the next sample to come? Burası açık mı arkadaşlar? Is this part clear? Is this part clear gençler?
Yes, hocam.
So there are, even though there are 6 samples here, I have to think in terms of how much time did it pass from one sample to the next one. So if I have TS, 5 TS being equal to 1 second, TS is gonna be 1/5 seconds, right? So what is my sampling frequency? 5 Hertz. Are you with me, guys? So we have to think in those terms. For example, if I tell you, bakın şöyle bir, if I give you, now I want you to do it on a piece of paper on your desk. Okay, this is my sine wave. Okay, so let's say this is 1 second. And this is 1 volt. This is minus 1 volt. Okay, what is the frequency of this signal, of this periodic signal?
3.
1, 2, 3. For 1 second, I have 3 cycles, değil mi? So that means my signal's frequency is 3 Hertz. Değil mi arkadaşlar? This is not sampling frequency. This is the frequency of my periodic signal. You understand what I mean? Yes? So, now I want you to perform a sampling whose sampling frequency is let's say 6 Hertz. Our sampling frequency is 6 Hertz. What do I mean by that? I have to have 6 samples in 1 second. But please bear in mind that don't count the one, the initial one, okay? The initial one is already there. Then now I'm gonna collect 6 new samples. How should I do it?
Hocam, the initial value ile first sample between these two.
Yes.
Also the first sample and the second sample. these intervals should be equal, right?
Yes, exactly. What you are saying is like the time between the zeroth, the initial sample, and the first sample is going to be TS.
So
Time
then
1 and 2 will also be TS. What is TS here?
it is pi over 2. Yes.
If this is 6 Hertz, sampling frequency is 1 over 6, right? Because this is my sampling frequency is the inverse of sampling period. What does sampling period mean? How much time will I wait for the next sample to come? This means sampling period. Okay? 1 over sampling period is going to be sampling frequency. 1 over this is going to be sampling frequency. Burayı anladık mı arkadaşlar? Is this part clear? So now I want you to tell me what is x of 2? What is the value of x of 2 when you do the sampling? Write to chat, please. Tell me what x of 2 is. Everything will start from x of 0. Nurefşan said -1. Any other guesses? Arkadaşlar, what is the time here? What is the time here?
1 over 3.
1 over 3. 1 over 3 seconds.
Not TS, 1 over 3, yeah.
How about this one? 2 over 3
Over 3.
second, right? So this one is 3 over 3 second. So what is my TS? 1 over 6. So where is 1 over 6? Here, right?
Half of that, yes, true.
This is 1 over 6. 2 times 1 over 6. 3 times 1 over 6. 4 times 1 over 6. 5 times 1 over 6. And 6 over 6. Where are my samples?
On the axis.
On all the values are 0, right? Değil mi arkadaşlar?
No.
So if I drove the discrete time version, everything is 0, right? Even though my signal is sinusoidal. Interesting. So choosing the sampling frequency is so critical that it will change your discrete time signal dramatically. So what do you offer arkadaşlar? What should we do to overcome this problem? Yaşar, what do you think?
Delay.
What do you think? How can we overcome this problem?
We can change the time delay, maybe.
What do you mean by time delay, Yaşar? What is time delay?
Changing the range of the samples, maybe.
Changing the range of the samples. I
Time
couldn't
range.
understand. What's that?
Changing the time range.
Changing the TS, you mean, right? Sampling
Yes,
period.
hocam.
So changing this Do you want to increase TS or do you want to decrease TS? Do you want to increase the time between two samples, or do you want to decrease the time between two samples?
Decrease.
Decrease. Why, Anya? Why should we decrease?
I don't know. If we decrease, we are going to increase FS, and maybe it's going to solve the problem. I'm thinking about the solution of the alias, and that's why I'm saying that.
So think about this arkadaşlar. Bakın, I have this signal. Okay. Now I am sampling like that. At every 1, 2, 3 here. Until here I have my, ops ya silip duruyor ya hepsini. Güzel çizemedim. Okay, this is my sinusoidal signal, whose frequency is 3 Hertz. And if I perform sampling with 6 Hertz, I only got zeros. What was TS for this? 1/6 seconds. What does it mean? There is 1/6 here, 1/6 here, 1/6 here, 1/6, 1/6, and 1/6. These are all seconds, okay? If you want to see a better representation of the continuous time signal, if you would like to see better representation of the signal, for example, if I would like to have such a discrete time signal. Is it a better representation arkadaşlar?
Yes, I don't. This is better.
Is this a better representation than this zero stuff?
Yeah, this one is better.
What did I do to have a better representation of my continuous time signal?
More samples.
More samples. More samples means increasing the sampling frequency or decreasing the sampling period. So I decreased TS, but bakın, it was here very big, now it's very small. Oh, very small, very small, very small, very small. So if TS is small, that means the time period between two samples is small, then I can have a better sampling. Burası anlaşıldı mı gençler? So decreasing sampling means the difference between two samples will be smaller than it was before. If I decrease this TS, that means the number of samples in 1 second will increase or decrease. Will decrease or increase? Which one? Yasir Çibel, what do you think?
I will increase.
It will increase, right? So
Yeah.
I will increase the number of samples that I'm collecting, that I'm sending to my computer. So it is critical for us to determine the sampling frequency in a sampling process. How do I determine? As Süleyman said, if I decrease TS very much, if I decrease TS so small that then it will be like, it will be almost like a continuous signal, okay? But why can't I increase TS so much? Why can't I increase or decrease TS to 0, almost 0?
Because there is not enough memory of bit range in computers or systems.
So memory is a problem. Any other problems that we might face?
Hocam, delay of the components.
Delay of the components, like we are dealing with electronics, right? We are dealing with transistors. There is a kind of limitation of those transistors going from and sampling something and then keeping it there for some time, okay? There will always be limitations regarding the sampling, regarding the electronics. Arkadaşlar, you know our cameras, our cell phone cameras take pictures with 30 hertz. That means 30 frames per second. If I have a better cell phone, it might go up to 60 frames. Or with some slow motion stuff, it goes up to 240 frames per second. That means it takes a picture every 1/40, 1/240 seconds.
Hocam, what about our eyes?
Our eyes are thought to be collecting data like a continuous process. It's not like sampling. It's like always like analog sensor. It's like a sensor. But cameras are like digital stuff. So they have to keep everything in a certain instance. That's like sampling. Okay, this is a sampling process.
I saw a lecture on MIT that says that the eye samples pixels, samples data as well. Then maybe it's like samples too many so that it appears like continuous.
In terms of pixels, that is correct. Like people say that it goes up to many gigabits, megapixels or gigapixels, very high pixelation, like it can differentiate. What does pixel mean? The amount of like the level of differentiation between two very close things. If I can differentiate these two things next to each other, then I can see it with that detail. So that means my pixel resolution is that. If I can only differentiate these two dots, then my resolution is lower. If I can do it in very small, if I can differentiate very small two dots, then I can say it's resolution. So in terms of resolution, it's very high, and it has some digitization as far as I know. But as far as I know, like the information is coming. Maybe it is limited with the neuronal transmission, neuronal transmission speed. Okay, that may be the limitation over there.
Yeah, I think, yeah, something like that.
Here, the limitation is coming from the electronics. In our brains, the limitation is coming from the neuron spike speeds, let's say. Okay, so you know our brain generates action potentials like that. Okay, it's like this, and sometimes it's very close to each other, but there is still a limitation for any two spikes to occur like consequently. So that may impose a limitation. As far as I know, the length of each action potential is like a couple of milliseconds. That's why maybe our vision has some kind of sampling limitation. So that's another issue that you may understand. Bakın buradan I would like to go here. 240 frames per second. Have you heard of any 100,000 samples or frames or images per second cameras? Have you heard of such a camera arkadaşlar? 100,000 images?
Maybe professional small motion cameras.
Professional small motion cameras, just like a bullet, tracing the bullet's movement. Have you heard of, or have you seen any such videos arkadaşlar, slow motion of the bullet that is entering a watermelon or something like that? Have you heard of, or have you seen such things?
Yes, hocam.
Yes. So are they really cheap stuff or really expensive stuff?
Expensive.
Expensive one.
They are really expensive because the electronics is very specific and very expensive. The cost of these kind of cameras are really high. Okay, so maybe $1,000, couple of $100,000, couple of maybe $1 million. Okay, so that's why sampling like this becomes not feasible, and even it is not necessary for certain cases. Neydi arkadaşlar? Now I would like to move on to the topic called Nyquist rate. Nyquist rate or Nyquist frequency. Okay, what does Nyquist frequency? Nyquist frequency. Emre said Fs over 2. Any other ideas? What does, arkadaşlar, I hope you watched the video, so you should be knowing it. Iqbal said the highest frequency of a band limited signal. The highest frequency of a band limited signal. Iqbal, what does band limited signal mean? My friend, what does band limited signal?
Hocam, it's limited by the, I don't know, like omega m or frequency.
Mean like this, huh? Omega.
Yeah.
There is the omega n here. What does this mean? What do you understand? How do you interpret this signal? What does such a Fourier transform tell you?
Periodic.
It says, I mean, the sampling frequency should be greater than double the size of the maximum frequency of this band limited signal. That's greater than 2 omega n.
What does this omega n mean?
The max
highest
frequency
in the signal. The highest frequency in the signal. What do I mean by highest frequency in the signal?
Hocam, we can represent the signal with different sinusoidal signals, pure sinusoidals, and they all have different frequencies and different amplitudes. So the highest frequency sinusoidal is Vn.
Very nice, very nice. Thank you very much, Mustafa. So what does Fourier say? He said that I can represent any signal with the linear combination of different frequency sinusoids. I will add many sinusoids to synthesize a signal. Or if I analyze my signal, I will have different sines and cosines which constitute that signal, right? This is what Fourier says. So what does highest frequency or maximum frequency mean? In my signal, what is the highest sinusoidal signal that contributes to the signal? Anlıyor muyuz gençler? For example, if I have this component in my signal, this component in my signal, and this component in my signal. Okay? Let's say one of them is 1 Hertz, the other one is 10 Hertz, the other one is 50 Hertz. If I add these up, I will have such a frequency, okay, such a signal, let's say. You got me, guys? I can add them up and obtain this, or if I analyze this and see what kind of frequency components I have in the signal, I will see I have this frequency component 1 Hertz, I have this frequency component, which is a little bit slower in terms of amplitude, in terms of contribution. And I have a smaller amplitude but higher frequency component. And this will constitute, oluşturmak, this will constitute my original signal. This is what? Frequency transform, right? Fourier transform. If I have the signal, I can go back and see what kind of contributions I have in terms of sinusoidal signals, pure sinusoids. So what is my maximum frequency here?
50 Hertz.
50 Hertz is my maximum frequency. So if I draw the Fourier transform of the signal, how do I get? What do I get? Let me draw again. Do you understand what I have done here? Arkadaşlar?
Yes, hocam.
Transform.
This is the Fourier transform of the signal. And how did I plot this? Firdevs? Şahane Firdevs?
Yes, hocam.
How did I determine these amplitudes, these frequencies?
According to these different frequencies.
According to these different frequencies and their amplitudes, değil mi?
Yes.
Because this is a smaller signal, my amplitude is small here and here. My amplitude is medium size, so it is medium size here. My amplitude is maximum here, my amplitudes are maximum here. What is 2 pi? What's the frequency of 2 pi radians per second?
1 Hertz.
1 Hertz. This is 1 Hertz component. This is 10 Hertz component. And this is 50 Hertz component. And they're counter ones in minus omega, right? Minus 2 pi 10, minus 2 pi 50. So what is my omega n? As I showed you here, this is gonna be my omega n. So what should I be doing in terms of sampling? If I say sampling is very critical, the sampling frequency is very, very critical. We have to be very careful about determining our sampling frequency. Why is EEG signal 128 Hertz? Why do we not use 10,000 Hertz? Why in certain systems we need to use 1 kilohertz sampling or 1 gigahertz sampling? Why do we need all these kind of things? It is all related to our signal that we are interested in. If we know the signal is band limited and it has a maximum information carrying frequency component, yani if I know that this is 50 Hertz is critical component, that I have to keep it in my signal. Bakın ne olur eğer omega'yı doğru seçmezsek, I will lose information. What was the name of this concept arkadaşlar? Losing the high frequency components by selecting the sampling frequencies in a wrong way. What is that?
Aliasing.
It is called aliasing. Duydunuz değil mi bu tabiri arkadaşlar? I will write it here, aliasing. Some people also read it as aliasing. But doğrusu alias. Alias, what does alias mean? Alias? Alper? What does this alias mean?
Hocam
Normally we use alias as, bir girin bakalım Google Translate'e alias yazın bakayım bir.
Fake nickname.
Nickname, alias. Neydi Türkçesi? Alias, nickname. Edebiyatta kullanıyorduk arkadaşlar, edebiyatta. Literature.
Mahlas.
Mahlas. Okay, in high school you learn this rumuz, mahlas. Okay, it doesn't have any relationship between this, but I want you to remember this alias, okay, concept. But aliasing means losing high frequency components and related information. Arkadaşlar, I know that there is a very critical information in 50 Hertz, but I have my sampling frequency is 50 Hertz. If my sampling frequency is 50 Hertz, what happens? What happens? There will be an overlap, değil mi? Hatırlıyoruz değil mi arkadaşımızın anlatımından?
Voilà.
You remember this overlap, right? This overlap? It's called aliasing. We lose information in this region, which is called high frequency region. Yani bu, it looks like, efendim Nurefşan?
If it is equal, it says there won't be overlap, but it will start when it's ending, then it starts.
Very nice. Yes, that's why we have to select our sampling frequencies in such a way that this is like, this is omega n, right? Maximum, sorry. So this is omega n, and what is this one? This is omega s. What is omega s? Sampling frequency. Omega n, maximum frequency in my signal. Let me write again. Omega n in radians per second. It means maximum frequency component. What is omega s? Sampling frequency. Anlıyor muyuz? Sampling frequency should be at least 2 times omega n. Bakın, omega n, omega n, omega s should be at least 2 times omega n. This is called Nyquist. You will hear this a lot, okay? Nyquist rate. So 2 times the maximum frequency. What was my maximum frequency in this question? 50 Hertz. What should be my sampling frequency? My F max in this previous question, it was 50 Hertz. What should be my FS arkadaşlar minimum?
100.
100, right? It should be minimum 100.
It's nothing omega.
Yeah, this is omega s, right? Or Nyquist rate. Yani I have to sample my signal by being aware of the maximum frequency of my original signal to be sampled. Anlıyor muyuz arkadaşlar? How do I make sure that my signal's highest frequency is 50? How do I make sure So if my sampling frequency in EEG signal that we have given to you, if it is 128 hertz, what is my assumption? Süleyman, what is my assumption?
What do you mean by assumption, hocam?
If I choose this FS, what should I accept?
64.
So I should say that F max is 64. That means I can only sample frequencies up to 64 hertz. I cannot go and sample 100 hertz brain oscillations. Anlıyor muyuz gençler?
Hocam, what did you say in last sentence? We cannot sample, we cannot represent, we cannot see the details related to 100 hertz oscillations. Bakın bir örnek göstereceğim arkadaşlar. If I have this signal, okay, it has many different frequency components, değil mi? Like slow waves and fast waves, and even here, let's say I have something like that. How should I determine my sampling frequency? I will look its Fourier transform, FFT.
I will have an FFT. In which part? Bakın, this part, this part, this part, or this part? 1, 2, 3, 4. Which part represents the highest frequency component, arkadaşlar? 4, right? 4. So the fourth part tells me I have a very fast action in my brain. So if I select my sampling frequency, benimle misiniz gençler? Beraber miyiz? If I select my sampling frequency like this, will this be enough to sample this part? What will I have? Hop, hop, hop, hop, hop, hop, hop. Will I be able to see the details in this highly like fast changes in my brain? Will I be able to see, observe those fast changes? Like this camera arkadaşlar. If I move like that, hop, hop, hop, hop. Can you see? Can you see movement? Yes. If I do this, can you see all the details here? No. You need to have a slow motion camera, right? For being able to see it. That's why if we are sure that this signal will have maximum frequency component like that, then I should arrange my sampling frequency taking this into account. Only this component into account, right? I will have such a thing, and this one will correspond to this one. This is omega. This part slow changing is somewhere here, fast changing in somewhere here. Components that are corresponding to high frequencies will be lost if I do not choose my sampling frequency appropriately. What does appropriate mean here? At least 2 times my highest frequency. But let me underline, usually we choose 5 times sampling frequency or 10 times sampling frequency. Sorry, we choose 5 times F max or 10 times F max. Why? I can show this to you on a simple sinusoid arkadaşlar. Biraz evvel gösterdim değil mi? How was my signal? My signal was 3 hertz. I sampled with 6 hertz and I only got 0, 0, dana gözü. Okay? So only zeros. What kind of a sampling is this? Was it a successful sampling? Even though I used a number which is Nyquist rate, which obeys the theory, but in practice, we have to be sure that I have to increase the sampling frequency in order not to lose any critical high frequency components. Bakın, if I increase this not from 6 to 12, then I will have 1 over 12, 1 over 6, 3 over 12, 4 over 12, 5 over 12, and such. Then what kind of a signal I will have? It is not still a good representation, right? It looks like this. It looks like a triangular wave. Arkadaşlar anlıyor muyuz gençler? Sessiz çoğunluk.
Yes hocam.
Anlıyor muyuz? So if I increase it from 112 like 12 hertz to 24 hertz, what happens? Then I will have one sample here, one sample, one sample. So what kind of a sample would I have? Is it still a good sampling?
No.
Looks like no. So especially in sinusoidal signals, we have to increase our sampling to like 5 times or 10 times our sampling, our maximum component in our signal, okay? So if you do this in MATLAB, I hope you have done it because I asked you to do it. If you increase the sampling frequency or decrease the period between 2 samples, you will see that it will be a lot closer to a sinusoidal signal like that. Okay? So what is my message here? We have to, in theory, we have to make sure that our omega S should be at least 2 omega n or omega max. But in practice, omega S is usually 5 or 10 times V max. Okay? So why is this? Avoid aliasing. Hemen hemen her doktora yeterlilikte her sınavda böyle bir şeyler soruyorum, bu anlaşılıyor mu diye. So we would like to avoid aliasing. What does avoiding aliasing mean? I will try not to lose the high frequency components by making sure that this omega S is more than omega max.
Is it different than avoiding overlapping?
Same thing. Overlapping means aliasing. Aliasing means overlapping. So same thing. Okay? Overlapping in frequency domain means aliasing. Anlaşıldı mı gençler? Burası. Şimdi bayağıdır birlikteyiz. Bir şey göstereceğim, sonra da bitireceğim birazdan. Şöyle yapalım. Gördüğünüz gibi Fruit Ninja'yı ben oynamıyorum arkadaşlar. Yanlış anlaşılmasın. Arkadaşlar, this is a final exam question from 3 years ago. I want you to look at the question right now. Görüyorsunuz değil mi gençler?
Yes hocam.
So, tell me the answer for A, please, in chat. Mustafa, Ahmet, good job. I'm asking you not the angular frequency, but in hertz. In hertz. Very nice. 2 hertz, right? How do you determine that 2 hertz? This divided by 4 pi divided by 2 pi, right? So omega divided by 2 pi will give you F. That means 2 hertz. When you see 4 pi t, it means 2 hertz. When you see 6 pi t, it means 3 hertz. When you see 20 pi p, 20 pi t, it means 10 hertz. You get me, right, arkadaşlar? So, can you plot this signal on your own, on a paper? Please plot it. I want you to plot it for 1 second. So, is this a cosine signal arkadaşlar? It's a cosine signal, right?
Yes.
Yes.
So, okay, I now want you to read this part until here. What kind of a signal would I have as the sample signal? Now I'm going to go from here to my iPad arkadaşlar. Okay, I hope you can see, you can still remember. So what was my signal, x of t? 10, 100 times
Cos 4 pi t.
4 pi t, right?
Yeah.
So what does it say? I should first amplify by 40, then sample with 16 hertz. Today I'm going to talk about quantization step, okay? Today I want to make sure that you understand the sampling theories details. One, aliasing. Two, what does it mean to sample something? What is the effect of frequency, sampling frequency, those kind of things, okay? Şimdi, if I want you to plot x of n right now. How do you plot x of n? X of n is x of t goes and is amplified by 40. Then there is a kind of sampling. And then conversion from continuous time to discrete time. And then I will have x of n. This was millivolt. When I amplify by 40, what's its new voltage level?
4 to minus 4 volt.
4,000.
4,000 millivolt, which means
4 volt.
4 volt, right? It will change from minus 4 volts to minus 4 plus 4 volt to minus 4 volt. Is this correct? Is this plot correct, arkadaşlar?
Yes, this is cosine.
And I wanted you to plot it for 1 second, 0 to 1 second. What was my frequency? F, 2 hertz. So 1 and 2. So I should come here. What is the value here? What is the time here?
0.5.
0.5. Here, 25. Here, 75, right? Herkes buna benzer bir şey çizdi mi arkadaşlar? Yes? So, how about 16 hertz sampling? How do you do it? What was 16 hertz sampling? How many samples, except for the first one, how many samples should I have until here?
16 samples.
16.
16 samples between 0 and 16 samples, right? So what is x0?
1. 4.
X0, 4 volts, very nice, 4 volts. What is x1? Ne yapacağız o zaman? Bir sonraki adım ne arkadaşlar? I should divide this part
T equals 1 over 16, I guess.
into 16 equally spaced portions. So I have to have this one should be like 1. 1 is going to be at 1 over 16 seconds. 2 over 16 seconds. 3 over 16 seconds. 4 and such. We will have 1 over 16 second is going to be the first sample, right? If I write x of t, let's say xa of t, it's amplified at 1 over 16, can I find the value? 4
Yes.
times cosine 4 pi times 1 over 16. I can say 4 times cosine pi over 4, which is 4 times root 2 over 2, 2 root 2. Is this correct, arkadaşlar? So what is x1? 2 root 2 volt. So here, what is the sample here arkadaşlar? What is the sample, the number here?
8.
8. What is the sample number here?
4.
4. What is the sample number here?
2.
2. So my sample, the first sample should be somewhere here. Look, first sample here, x0, x1, okay? x2, x3, x4, x5, x6, x7, x8, x9, 10, 11, 12, 13, 14, 15, 16. So by looking at this, can you tell me what x of 3 is?
Minus 2 root 2.
Minus 2 root 2. Very nice. Minus 2 root 2. Because it is this one, right? Bakın 2 root 2, 0, minus 2 root 2, minus 4, minus 2 root 2, 0, plus 2 root 2, 4, plus 2 root 2, 0, and so on. Did you understand what I have done? What kind of an approach I had in this question?
Yes, hocam.
Yes. So I have 4 here, 2 root 2 here, 0, minus 2 root 2, minus 4, minus 2 root 2, 0, plus 2 root 2, plus 4, plus 2, and so on. Okay, I couldn't draw everything in appropriate sampling, but this is the main logic. Is there any missing points, arkadaşlar? Is there anything that you have not understood so far? Because this is critical for you to understand. I think we will have such a question in the third integrated quiz. So at least in my own sub-component quiz, next week I will want you to do such a thing after I cover the quantization part. Okay, if you understand this part, the quantization part will be really easy for you.
Hocam,
Yes.
we always show the Fourier transform of the message signal as a triangular signal. Is it always like that?
Nurefshan, it is just a model. Okay, good question.
Okay.
In some questions, we say that this is our x of j omega, but it may be something like that, as I have shown you before. Only sine or cosine. If I have only sine and cosine, I would have such a thing, right? I may have something like that. What does this mean? I have higher components in the low frequency range and lower components in low frequency range. I may also have this. What does it mean? I have higher components, more let's say, more weighting components in the higher frequency range. It is just to represent or show the sampling concept, okay? It shouldn't limit your understanding. It is just a representation of a band-limited signal, okay? This is also a band-limited signal. This is also a band-limited signal, okay? But this is not a band-limited signal, for example. This is not a band-limited signal because it says I have all frequency components. Okay? If I would say is this a band-limited signal? Yes. because my frequencies that I have in my signal is limited here. But here, all frequency components. Okay? Tabii discrete time'da this is like the highest frequency available in my signal bu arada tabii. Aman şimdilik kafanız karışmasın. Okay, so this thing is just a representation for us to understand in order to show the overlapping stuff. If I have such a signal and if I have an aliasing effect, I will lose all my data because all the information is in the high frequency range. Değil mi? Bakın arkadaşlar. If I have this as my signal, frequency, Fourier transform of my band limited signal. Okay? Let's say this is omega n. If I sample it like this, omega s is here. What should I have? Where is the overlap? What does it mean? Geçmiş olsun. Allah rahmet eylesin. All my signal will go. Because all my signal is in the high frequency range. All my information is in the high frequency range. That's why I have to keep my sampling away from the other one, okay? So there will be such a tolerance, there will be such a security region, okay? That's why omega s should be selected critically, should be selected carefully. Şimdi, for example, arkadaşlar, in EEG, if I'm interested in high frequency components, such as gamma waves, around, let's say, 70 hertz, and if I'm using sampling frequency at 128 hertz, this is wrong. I cannot sample gamma activity. But if I have 128 and I'm only interested in bands limited to beta waves, which is 30 hertz, right? Up to 30 hertz, this is appropriate. No problem. Anlıyor muyuz arkadaşlar? For example, in ECG, there are different systems with 100 hertz, 250 hertz, even 2000 hertz. What is the goal of using 2000 hertz here? Maybe there are very slight changes in the heart voltage, which will tell me something about the heart disease. That's why I may be interested in those details. Or if I'm interested in only the heart rate, I don't need to go up to 2000 hertz. Because I'm gonna need only these peaks. Okay? So for the detection of peaks, if I choose 100 hertz, that's fine. Anladık mı arkadaşlar? I think that's enough. Like almost 90 minutes. You are, I think you are exhausted enough.